We're going to illustrate how linear transformations work by looking at an exercise that involves transforming a little stick figure. We'll call the stick figure Timmy 2 space. This is an exercise that's inspired by Alan Klein, and it's been programmed up by Ben Holder. The blue figure is Timmy 2 space. We'd like to transform Timmy into various targets. Those are the light blue figures. So Timmy would like to be transformed, and the target is going to be the light blue figure. The one thing we know is that the transformation is a linear transformation. Now here's the idea. Timmy consists of many points. We're actually going to look at the vectors that point to all of these points. So imagine this point right here. We have a vector going from the origin to that point, and we're now going to have a linear transformation that transforms that vector into a new vector that points to a new point, the corresponding point in the target. And the idea now is that we would like to determine what the transformation is that takes this vector to that vector. As a matter of fact, that takes all of these points that make up Timmy to the corresponding points on the target. Now, there are many points. For example, just at the top of the head of Timmy, there are many points, and therefore we would have many vectors, each of which has to be transformed. Now, the good news is that if we take the two vectors that define the endpoints of the line segment that's the top of Timmy's head, then the thing that we know is that any vector that points to a point in between on that line segment is actually a linear combination of the two vectors that point to the endpoints. So any x sub I, which points to a point in the middle here, is equal to some multiple of x sub 0 plus another multiple of x of k minus 1 if this is the vector xk minus 1. What do we know? We know that if we then transform that intermediate vector, it itself is just a linear combination of the transformed vectors x0 and xk minus 1. So we know what the line segment will transform into if we just know how the vectors that point to the endpoints are themselves transformed. So Timmy likes this because this means we don't have to worry about transforming every point of his body. Now, let's look at transforming Timmy into the target, keeping in mind that we are only going to consider linear transformations. Here is the little tool that you're going to be working with. Timmy is going to be right there. The target is going to show up somewhere. We would like to determine the matrix that will transform Timmy from the original into the target. So we're going to have to change the values in this matrix to the values of the matrix that would be the transformation. Once you have filled in those values, you hit the button Timmy, which will transform Timmy. If you can't figure out what the transformation is, then you can surrender and see the answer, which will show up right up here where you should have filled it in. Once you're done with one transformation, you can go and get a new target and see if you can figure out a transformation that will transform Timmy into the new target. It may help to turn on the grid, turn on where the axes are, and turn on where the tick marks are on the axes. This is what it looks like when I start up the tool, and I would like to now transform Timmy into this target. Well, I could just kind of guess and see what happens. Maybe it's a matrix of all ones. Uh-oh, Timmy has become a line. That's not so good. What if we make this a 2? Well, Timmy looks a little funny. Certainly doesn't look like the target. Let's try something else. That doesn't do any good. No, I'm just not getting anywhere, so I need to be a little bit smarter. Let's see what I can do. I'm going to say 0, 1 and -1, 0. Ah, I figured it out. Go and try it. Download the file timmy.py. Once you have downloaded it into a directory, in the directory simply say python 3.3 timmy.py and off you go.